This is level 1, version B. So if at any time I go too fast in this video, hit pause and get caught up, or rewind and rewatch as many times as you need. I have 2 sets of this entire parenthesis. Inside each one, I have x, y to the 4th. This 4 is only on the y. So inside each parenthesis, I have x and then 4 of the y's. So x to the 2nd power, y to the 8th. Number 2, I'm going to expand all of these. On top, I have 4 r's, 3 s's. 9 r's, 2 s's. R divides into R 1 time. So anything that's identical to the top and bottom can cancel out with one another. All of these r's are left over and they're on bottom. S divides into S, S divides into S. I'm left with 1 S and it's on top. Whatever is left on top has to stay on top. Whatever's left on bottom must stay on bottom. M times N times another 6 M's for a total of 8 M's getting repeated through multiplication. Number 4. This 4 is only on the parentheses, not the negative. So 2b, 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 2b. And then this parenthesis is technically to the 1st power, so I just have one of those. 4, I'm going to expand it because I don't want to rewrite all of those 2b's again. So I have 3 a's right there and then 6 b's. Hopefully I don't regret eating up this space. So I have a negative, only one of them, so my answer is going to be negative. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 4, I think, is 64. Let me double check that. 16 times 4 is 64. Okay, so that's all of the numbers. And then how many A's do I have? Because I want to list these in alphabetical order. So I'm going to put the A first, but if you put the B first, that's okay. A, we have 3 A's, so A to the 3rd. How many B's? Well, we have, so we have 6 over here, 7, 8, 9, 10. For number 5, we don't want to deal with negative exponents. So I'm going to take this negative 5 and its base, and I'm going to move it to the opposite side of the fraction. So on top, I have 3h to the 7th times j to the 4th. On bottom, 5 times j times k, and now times k to the 5th. When this and its base move to the opposite side of the fraction, its sign changes. So if I rewrite this, on top, 3, and then I have 7 of the h's, and then 4 of the j's. On bottom, I have a j, a k, and then I have 5 more. Use a different color to eliminate these. This j can cancel with that j, so I have 3 j's left on top. And there's no h's on the bottom and there's no k's on the top. And 3 and 5 do not reduce, so how many h's? There were 7. How many j's are left on top? 3. 5 is on the bottom, and then how many k's? 6. So this is 4 times x times x times x, and then another 3 of those times, I'm going to put this in parentheses so we don't confuse it and think it means subtraction. We're multiplying by a negative 2. And then we have 3 x's. I'm going to put these numbers together. 4 times negative 2 is negative 8. Then how many x's do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. This entire parenthesis is to the negative 2 power, so I'm going to take it and its base and move it to the opposite side of the fraction. So on top, we still have a to the third b, but now on bottom, I have 3a to the third b to the second power, which means I have 2 sets of those parentheses. So inside each one, I'm going to try to expand this 3a, b, 3a, b. On top, I have 3 of the a's and a b. So these 3 a's can cancel with these 3 a's. This b can cancel with this b. If everything cancels from the top and what we have left over is on bottom, then your answer has to stay on bottom. And so this becomes 3 times 3, which is 9, a to the third b. But here's the thing. If I said I had $10, is that the same thing as having 1/10 of a dollar? It is not equal. So when we divide everything out and the answer's left on the bottom, then this is what we're dealing with, and we can't just magically get rid of the 1 in the fraction bar. It has to stay on the bottom, otherwise we've changed its value. Again, we have a negative exponent, so I'm going to take it and its base and move it to the opposite side. So on top, I still have w to the second to the third. On bottom is w to the 6, x to the third, and now x to the positive 4th power. And then I'm going to expand on top. I have 3 sets of w squared, so ww, ww, ww. And on bottom, 6 w's, 3 x's, and then 4 x's. W divides into w. And everything's gone from the top. W divides into w 1 time. So when all of these things cancel, I keep being left with a times 1, times 1, times 1. So I have 1 left on top. Same situation as the problem we did over here. And then all of these x's are on bottom. Finally, this 0 is on the entire parenthesis, so what this really is times 1. Because anything to the 0 power is 1. And anything multiplied by 1 is itself. You do not have to write the dot for that one. Again, if you need to, rewatch this entire thing as many times as you need.